So, hello, good afternoon. My name is not Josh Wagner, as you can see. I'm Jo Ameyer, working for the Fluitech company. Welcome to everybody. Possibly I should say good morning because we will also have participants now from cross Atlantic, from the Americas on board. I wish to welcome also Danny Shorten.
Hi, good morning, good afternoon, good evening.
So Danny is going to be our next speaker, um, and the way we will work with this presentation is that you will hear a pre-recorded session from Danny, which we will be running in about 2 minutes time from now. There, from that presentation on, it will take like 20-25 minutes. Once his presentation, his pre-recorded presentation is finished, we will give you the opportunity to, well, you can already chat via the chat box, you can launch your questions. I will record them, use them, and then put them on the screen so that Danny will be in a position to answer all your questions. And by this, I wish to uh, wish everybody another good LRVS session. So I will introduce Danny. Danny is the managing director of the Optimain Limited company. And the title of his paper today, which he will be bringing to us and discussing, is how to assess the asset population by using oil analysis data. Um, I want to repeat that if you have questions, just type them in your chat box. We will make sure that we have time at the end, and if not, then after that the chat will continue, and you can continue to ask your questions. So I'm gonna start running the presentation, uh, and we will then, of course, disappear from.
Hello, welcome. My name is Danny Shorten and I'm going to be taking you through the next 20 minutes or so a topic which is close to my heart, which is about how we can get more bang for our buck in terms of getting more out of our asset population data using oil analysis. Now this could equally apply to any condition monitoring process, but oil analysis is my thing, so let's talk about that. First thing though, just a little bit of an introduction. My name's Danny Shorten. I'm 56 years old. Why did that happen? Mechanical engineering principal consultant for a UK company called Optimain Limited. Optimising maintenance. That's a clever little play on words there. Myself and Rosie are parents to little Tilly, who's a little girl, 11. And we live in the south of England, near Bristol, just south of a town called Bath, which is very nice. I have spent 40 years, man and boy, in lubes, would you believe it? I looked the other day, I was 56 in May, and that means, because I started when I was 16, I've spent 40 years in the industry, with lubes, condition monitoring and maintenance optimisation. I really enjoy this. I've got to be honest, I didn't set out when I was 16 to get there, but by hook or by crook or by default, we've ended up here, and I really enjoy the work. I really enjoy the area. I'm quite passionate about it. But I started up as an apprentice, a mechanical engineering apprentice within a lubricants manufacturer, a specialist lubricants manufacturer, a company called Century Oils, indeed. I was the apprentice in their projects department, so we were building effectively lubrication plant for lubricant manufacturing plant. I spent the first 5 years doing my apprenticeship and doing some studies in day release and at night, and I moved out of that department actually when I graduated into a physical testing role, which was pump tests, gear tests, standard IP and ASTM tests such as 4-ball, FZG, Timken, etc. Low temperature pumpability of greases, fire resistance of hydraulic fluids, etc. Really good stuff. So I spent a few years in that area. I ended up running the place after a while, but all things come to an end, and I went out as a field engineer. So I took some of those skills, basic mechanical engineering, plus an understanding of how lubricants perform, and supported the commercial teams as a field engineer, doing lube surveys, product development, and problem solving effectively for our clients. Again, a wonderful, wonderful role. Open doors as you walk in. Not like being in sales at all, which I did do for a while, but didn't suit me particularly. Got involved with condition monitoring, oil analysis, also got involved with vibration analysis at that point, and also getting involved with developing on-site relationships. So we're actually putting people onto site to administer the lubricants from receipt to application and waste management. A pretty new concept for the organisation at that time. Again, all things come to an end, and I left the organisation in '99 to join Lloyd's Register as a senior surveyor, predominantly looking at deep sea marine lubrication, large two-stroke engines, four-stroke medium speeds, deck machinery, cargo handling machinery, and also in a separate world, which I spent a lot of time doing, analysis of lubricants, specifically greases and slewing bearings on offshore cranes. From that I developed into a lead specialist, where I was actually combining condition monitoring technologies with classification to learn and to help build a classification profile which allowed people to maintain assets in a way different to the OEM via condition. Left them in 2016 to start Optimain, which is where we're at now, and offer guidance, training, support in the field of predominantly lubrication, condition monitoring, asset management and reliability improvement. And I am genuinely passionate about improving reliability. Not necessarily from a design point of view, because assets are as reliable as they'll ever be the moment they're installed. But we do a lot which we can improve to reduce reliability when we're lubricating. We don't look after the oils, we don't understand how the oils are telling us about the plant. So there's a deterioration in reliability opportunity due to poor management of lubricants. And I believe wholeheartedly that we can get more bang from our buck by managing our lubricants better. Now, what we don't do is look at our assets very often as a population, and we'll get back to that because I think that gives us a little bit of a spin that we can take advantage of. My company is a company called Optimain. There we go. And that's about maintenance management optimization. We're an independent consultancy. We're focused upon improving reliability via strategy development within the organisation. So putting maintenance management at the same plane as health and safety and quality. Normally, maintenance is buried in the quality management package and buried in the safety management package. But actually, if we develop a reasonable policy, we can develop the right strategies, and we can make sure we have a top-to-bottom approach to how we look after our assets. They are invariably the core of our cost base, and we don't really look after them very well. Okay, less about me. Let's get into the topic we're going to talk about. Okay, the way the presentation is going to run is I'm going to state a situation which I believe we can respond to, which will lead to an opportunity for benefit which you can enjoy, and the strategy by which you can achieve it. It's not high level stuff. It's fairly obvious actually when you say it out loud, but a lot of people don't do it. They're not doing it at all. And we'll have a look at an example with some results just to illustrate what we're trying to get at. But the question we're trying to respond to is that we know we have a lot of condition monitoring data, and we know there's much value buried within it, but how do we get it out easily without having to spend lots of time running spreadsheets and building graphs and building trends? Well, the answer to that simply is to do it as the data goes into the database when you're actually doing each individual assessment. And what I mean by that is our oil analysis reports, and for that read its condition monitoring reports, are very often viewed as static historical documents. They record a sample, the condition of the lubricant on the day it was sampled, a report is generated. It may be tacked onto a few historicals to create some kind of understanding of movement and trend. But we only really respond upon the red, amber, green status of these reports. Red being action, amber being caution, and green being no significant issue. Statistically, the mathematicians would let us have some kind of confidence in these results if we had 8 sets of data, either 8 sets from one piece of kit or 8 similar pieces of kit with one set of data. That gives us a statistically reliable data set. Apologies for the screen, by the way, there's been a bit of a weird thing going on with the words there. I'll fix that. We very often archive it without further analysis. So we look at it, if it's red, we do something maybe, if it's amber, we go, okay, and if it's green, we file it. Now the proportion is normally about 75% or 2/3 of the reports we get from our fleets or population should be green in good order, no significant issues. We'd also expect 20% to be at some kind of cautionary level and 5% requiring some kind of intervention or action. That would be normal. The ideal, of course, is 99% green, 1% action, no reds. But that doesn't normally work out because as we improve, we tend to tighten limits, we tend to look more closely at change. So this sort of proportionality is a good benchmark to work from. Early detection with oil analysis reports is often considered the most important attribute, and we forever see in PF curves showing whichever condition monitoring tool is on sale on the day is shown to be the most sensitive. And we all know that different techniques are sensitive to different failure modes, but it's all about detecting things early, i.e. stopping major failures, and that is completely understandable, but we're missing a trick here. We are missing looking at the data for business as usual across the population, because there are lots of subtle changes and differences in the data which lead to significant opportunities for improvement, or at least targeting improvement policies where before we had no means to understand them. So the opportunity that I'm trying to exploit and share with you is the fact that most issues represent in our trends before any alarms are breached. There's many times we've had failures and we go back and look at our data and we can see some kind of trend change, but it's not significant, but we can see it's changed and we can see that it's related to the failure. Also, most sites have multiple similar assets and most failure modes are similar across similar assets. So we can learn from one machine and inform another, again, which we don't very often do. Now, in simple terms, most of our failure modes can be grouped into 3 headlines, such as internally generated, externally generated, and those which are due to housekeeping issues. And if we dig down a little deeper on there, we can find that there are a number of causations which would generate the headlines. So we can look at internally generated issues such as wear, water due to condensation, oxidation due to heat, etc., or externally generated, such as an extreme external environment and the variability of that environment leading to hot and cold spots. Dirt ingress due to literally the environment or seal breaching, and housekeeping, for instance, not using the right oil, not writing the right name on the sample pot, not cleaning filters, not changing them often enough, or general lack of care or ignoring systems so they deteriorate to a point of fault or functional failure when we could have actually maintained them in a light way and prevented that. So the failure modes are fairly broad. They're not particularly detailed technically, but within our oil analysis reports, we normally report on the condition of the oil, the condition of the contaminants, and whether something is internally or externally generated. So if we're reporting due to poor viscosity or because we've got high metals or we've got high water, we can appoint a failure mode to that at the point of reporting. So if we add failure modes codes, should we say, to all our red and amber reports, we'll start to be able to build up a second tier of condition monitoring. We'll be able to ask why the reports are not green. We can also group all similar machines, irrespective of what they're called on the plant, because we know local people use local descriptions, but we use similar machines and group them by some means. and don't use nicknames as their headline, then we can slice and dice the data, so we can compare gearbox A with gearbox B, we can compare gearbox type A with gearbox type B, or gearbox on site A with gearbox on site B, and so forth. Really, it really depends how we want to slice and dice it. So we need to consider at some level which asset groups are important to you, and how we're going to actually look and compare that data. So is it by make, or by type, or by function, or by criticality? These are things which need to be considered at the local or management level within the company. And also, clearly, if we're looking at these things in a quality management way, we need to be able to consider some of these outliers, these red reports, as effectively non-compliances. And we need to put a date by which they're improved by. And in order to do that, to get rid of our non-compliance, we need a period of time. And then we need to measure that we've actually successfully improved that. So if we perform some kind of Pareto analysis, let's say on the last 6 months, and then do it again in 6 months' time, we'll be able to see if some of the faults that we identified we've actually been able to improve. And that's bottom line savings, that's real money. So here's an example. Company A, I've got 13 ships, they've taken 469 samples, and 18% of them are red, 14% of them are cautionary, and 68% of them are green. That's a headline. Now, the first thing we can say here is we've got far too many red reports. We need to push them into caution. So we've got some actions to do, but what sort of actions do we need to do? We don't have any understanding here. So let's see if we can drill into it a bit data and see what sort of things we need to be thinking about. Well, if we split them up by the headline failure modes, so in this case we've got cleanliness, fuel, dilution, metals which don't look right, soot presence which is unacceptable, base number which is unacceptable, and viscosity and water which are unacceptable. And we can see the two hitters there are, we've got unusual metals and unusual viscosity. So it would be reasonable to suggest we've either got a housekeeping issue across the whole piece, or we've got some high degrees of wear, or indeed high degrees of oxidation. It's not particularly clear, so we need to drill a bit further down. So let's start looking at the types of systems. So if we look at these ships, we have a number of systems, and we're able to attribute the failure modes to each one of those. Now, admittedly, some ships have got more samples. Some systems are sampled more often than others. So we kind of need to normalise that at some level. But we can see quite clearly that we've got high levels of issues on cranes, high levels of issues on auxiliary engines. So we need to maybe dig in a bit deeper. Excuse me. If we, I'll just move that. If we look at the fault code or the failure mode, again, looking at whether these are actions or cautions, we can see actually most of the metals are cautionary here. They're not particularly significant, but they are of interest, and that could be grade. We're getting materials which don't look as if they're from a particular grade, whereas our viscosities are action statements. So if these are wrong grades, they're not just slightly wrong, they're completely out of context with what we expected to see. So that gives us a little bit more of a drill down, but still not sufficient to know what we need to do. We need really to look at both the condition and the type of failure mode against each asset type, which is what we're showing here. So I've got these drilled out into where the asset and the failure mode is shown against those which are amber and red. And there's another page of those, and you can see there's our auxiliary engines here. We haven't got fuel dilution in there. We've got fuel dilution in emergency generators. So that's locally a generator issue. Okay. We've got crane over here has got cleanliness issues. It's the only thing with cleanliness issues. So let's drill into the cranes. Why are we suffering on cleanliness on cranes when we do have other hydraulic systems, but cleanliness doesn't seem to be an issue? We'll drill down to that in a second, but some headline conclusions that many grade issues across the piece suggest a need to check all the data and verify that all the grades are as expected. Maybe we've got dirt issues or top-up points that are not labelled. So there's some basic housekeeping stuff we need to probably just get our heads around. The emergency generators suffer from fuel dilution. That's kind of expected, I suppose, but the data does prove it. We have ongoing water issues in hydraulic grabs. But the crane hydraulics, which is what I'm concentrating on here, have cleanliness issues across the piece. So we need to really dive into that and look at what that means. Possibly then do some assessment in a further 6 months to see what that comes out at. So if we look now at the cranes, this is the headline data here. But when we split them out into the manufacturers, we see that actually crane make C is, it's had 8 examples where viscosity isn't good. We've also got issues around crane make D where cleanliness and metals. So we've got different issues on different crane types, which means now we can really dive in and try and understand what's the case there. Now we could slice and dice this further to get to the root cause of this, but we haven't got time in this presentation. Needless to say, I could create, and I would recommend creating some kind of management report which pulls things out in a similar way to this, so we can look at the things which are relevant. Now, if we look at this population performance review from a position of machinery or people, from a machinery perspective, we can turn this failure finding tool into an assurance tool. We can actually demonstrate ongoing suitability for further service for all those assets which report green reports. We can then add value by looking at why certain assets suffer more than others, and we can compare asset types, possibly for decisions such as purchasing making, and really see which ones work best in our environment. And we can make optimization our core activity when looking at maintenance as opposed to being repair focused, which affects the people as well, because we can look to see if we've got operational issues across the plant and compare plant with plant, as it were. And we can see if lubrication management requires revision. Is oil cleanliness or the oil stores or the way we deal with lubricants somehow impacting upon the reliability of lubricated systems? We can then go further if we have a multi-site organisation and compare site with site, and then try and drill down and understand why some sites fare better than others. And we can reward good maintenance by demonstrating assurance, because our engineers predominantly get a pat on the back when we fix things that are broken and get the plant running. Well, we don't want the failures in the first place, so how do we reward them by not having failures? Well, that's by documenting and by proving that their activities in optimization are actually adding value. And that, I think, potentially is more interesting work, because you're actually turning people onto failure avoidance and not being repair focused. You're not effectively blue lighting every failure. These should not be an emergency service. These should be preventing issues. So, coming to the end, the overall points to take from this is that, in my opinion, and many would agree, that a well-defined quarterly management report in a similar style to what we've walked through here has significantly more value than any individual test report, because it allows you to go through the improvement and optimization process. So without adding much cost, much more value can be gained by taking this higher level view of your data set. And of course, once you've prepared that report, you can automate that. So it's literally a click of a button, and every quarter you can update that and look at it at a management level. And what that also does is it gets management interested in the data. Very often there are, if you like, pioneers within companies who are very supportive. They're champions, if you like. And when they move on, what their good work is not necessarily culturally embedded. Whereas if you can use this kind of management reporting process, then you can make it interesting to those people who are looking at things from a bit of a higher perspective. And then, of course, you can slice and dice this data to define any question that your KPIs are asking of you, which is really, really useful, because it takes something that might be a standard oil analysis report, which is formed by your oil analysis provider, and then put it into a way which is highly specific to your environment, highly relevant to your environment. So these reports can be used to demonstrate ongoing good reliability, as well as searching for deeper issues where optimization and improvements can be sought. And ultimately, let's be honest, if we don't measure things, we can't really manage them, because we can't demonstrate improvements or support, for instance, requests for finance to solve problems which need financing. So there we go. That's the end of my presentation. It's been rather hurried through, and I do hope I haven't gone over. So thank you very much for your time. I'd be very happy to get any feedback you have regarding the sort of concepts I've outlined here. And some of you may already be doing this, so this might not be particularly news to you, but you know, we've built a number of relationships with clients over the years where we've gone in and assessed what's important to them and then helped them to really focus their oil analysis data on the questions they want answers to. Because the service supplier won't be in a position to do that. In the main, some will, but in the main they are geared up to getting samples out to the lab and into your inbox. So I would suggest have a conversation with them to see if it can be done, and if not, you know, by all means have a conversation with us and we'll help you to achieve it. Anyway, that's me done. Thank you for your time and interest. I say apologies for it being a bit of a race through. I hope it was interesting, and I hope we'll get to speak to each other again. Thank you very much indeed. It's been a pleasure.
Wonderful, wonderful, Danny. That went really well. Congratulations. This was a very clear presentation, good points, just like one of your contacts, Andy Gailey, is saying, good points, Danny, shouting about the benefits by period, quarter, and annually is the best practice, Imo. So, hi, Mo. So, I think it's fantastic. We have not really questions till now, but you know what? But I was wondering how much, because I see your activity, which is quite vast. Do you spend also time on some of the handling and storage procedures? Because you know today when you talk about cleanliness of an oil. Which is added to, let's say, for example, a crane on a ship. How do you manage to, I would say, establish good handling and storage procedures for your customers?
Well, I think it's a continual issue across all industries, not just marine.
No.
Somebody once said to me, if you look at the price of a barrel of high quality gear oil, for instance, it's probably a bit more expensive than a widescreen TV, but you wouldn't store those in the sort of conditions most people store their oil in.
I love
Um, so
that.
it's quite a simple assessment. Would you put anything of value in the same place as you put your oil? And probably not. Um, I think housekeeping is very often one of the things which is overlooked. We get very excited about technology, but we don't necessarily get the basics right, and we expect technology to solve those problems. And I think it's a marriage of technology. It's one of the things going in to talking about the getting more asset value is, you know, all the oil labs I've dealt with don't put failure codes on their reports. All the data, all the useful stuff is buried in a free text field. So if you want to assess it numerically for thousands and thousands of samples, you've got to deconstruct the text code. Whereas if you can put a fault code in at the beginning, so it's a red report because it's hydraulic oil because it was wet, you know, then every time you want to check for wet hydraulic oils, you can slice and dice it and compare machinery with it. But we don't do that, which is the kind of the point then that I was trying to make was that if we look from a higher perspective, we can get a lot more information from what we're already doing for very little additional cost.
Absolutely, and in respect to that, I see here a good reply from Bob saying if you do use 80-20% Pareto split, that is famous Pareto law, is it then possible to do additional steps with RCA, root cause analysis, or what do you think?
Well, absolutely. I mean, I couldn't agree more with Bob's suggestion there that every time we see anything new, we should perform some kind of root cause analysis, at least to the point where we can control the inputs. And once we understand that, we can put some measure in place to avoid that. So I see it more like an outlier. Because when we set up our condition monitoring, whether it's oil analysis or any other, we're normally looking for failure modes that we're familiar with. But we can't plan for everything, so that we will have failures or excursions that we hadn't planned for. And the skill there is understanding those, performing root cause, and bringing them into the known light of confidence, so that we don't repeat them. And as one of my apprentice teachers told me, he said, "I don't mind you making mistakes, but I don't like you repeating them." And
yeah,
that's just using data wisely, I think, at the end of the day. I
yeah,
noticed Bob's also put up a note there about hunting with rifles rather than shotgun, which is also plays into my field really well, because if you well, I used to do some archery, and the first thing you need to do is be able to hit the board. You don't worry about the bullseye, yeah. The next thing you do is you bring your grouping together so you can actually hit the same place on the board. And once you can
uh,
do that, you then bring your grouping to the center of the target.
correct,
And this
correct.
is exactly the same with oil analysis or with condition monitoring. So you need
Yeah,
to understand why you're getting a spread and then bring it in. So I think you'll always get an 80-20 split, because
yeah,
even if you get rid of a number of red reports, you're going to then tighten your limits. So you'll just get a more sensitive system. And instead of then your red report saying you've got a broken gearbox, go and fix it, it's
yeah,
saying something's unusual about that gearbox, go and understand it. So you move into an optimization mode as opposed to a fixing or fighting fires mode. So there'll always be a split. Um,
yeah.
but I
So
think as
now,
you move forward and you get to understand your assets, you become more confident that your assurance going forward is maintained.
yeah. So great analogy with archery. Andy is saying. I noticed also, Danny. I was interested with the data on the cleanliness of on the cranes. We recently were involved with a similar application with increase of cleanliness, and mostly it was due to the presence of soft contaminants. Some of these you heard here about varnish components, which are picked up by ISO Prague accounting, but didn't see anywhere. So I think this is also an example of where we have seen this, where you see this 80-20% rule, then you go for RCA and you find out that the contaminants are not hard but are soft, and they created
Yeah.
because they've been mixing different type of oils, and so really. So let me look at some other comments here. I see here somebody saying here. So as
What
I
about a
told
six?
you,
What about a six string? Huh?
yes, we spoke about it while starting the meeting.
Yeah, yeah.
So
Now,
okay,
next to
good. Well,
lubrication, bass guitars are my passion, I have to say.
excellent. Well, yes, keep them both in good shape. That's the most
Yeah,
important.
yeah,
So good, good. Danny, it was a real pleasure to meet you virtually, but I hope one day I can meet you live and have some other discussions. There
yeah. It's
was
lovely.
a good feedback here from participants. Thank you also for your contribution to LRVS. I hope it's been also interesting for you. People who want to continue to discuss and have a question, they can still chat with Andy to the LRVS platform and other people and participants. In 2 minutes, we have another session starting. Oh, no, 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 there's a break. I see. I'm sorry. There's a break for 30 minutes, and then we will start in 30 minutes some another session. Again, thank you very much, Danny. Stay safe. All the
Yeah, thank you,
best.
everyone. And it's been great, very well supported, good tech, and great topics. So I've enjoyed it. It's been good to be involved. Thank you.
Likewise. Thank you very much. All the best. Bye, everybody. Bye. Bye.